To the first question, it is given that the length of the side of the cube is 2 centimeter plus minus of 4%. So length of the side will be how much? 2 centimeter plus minus percentage error is how much? 4%. Okay, right. Again, I can also write that the mass of the cube is 24 gram plus minus 8% also given. Mass is given 24 gram plus minus of 8%, right? Now we have to calculate the percentage uncertainty of the density of the cube, right? So that means density is what? Mass per unit volume, that is m by v, right? Now see, the quantities on the left hand side is only rho, that is density, and the quantities on the right hand side are mass and volume, right? Now what I can do is that, see, by the theory of errors, delta rho by rho, okay, so that means this was the only quantity on the left hand side, and for the right hand side there are only two quantities, that is m and v. So for m, what will I write? I will be writing delta m by m, right, plus delta v by v, right? So now if I just multiply both sides with 100%, so delta rho by rho into 100%, this will be equal to how much? Delta m by m into 100%, right, plus delta v by v into 100%, right? Now what is delta rho by rho into 100%? This is actually what? This is actually the percentage error in density, right? So this is the percentage error in density, rho. So this will be equal to the percentage error in mass, right, plus the percentage error in volume, right? So we know the percentage error in mass is how much? Plus minus of 8%, so right over here. So that means the percentage error in density will be equal to plus minus 8% plus the percentage error in how much? In our volume, right? But over here it's given that the length is given, not the volume is given, right? Percentage error in volume, right? So that means, see, over here we can also write v is equal to length into length into length, right? Volume is what? L cube, that is length into length into length. Again, see, on the right hand side, left hand side, we have only v, right? So that means on the left hand side I'll write delta v by v. Okay, now on the right hand side there are three quantities, L, L and L. So for the first L I'll be writing delta L by L. For the second length I'll be writing delta L by L. For the third length also I'll be writing delta L by L, right? So that means delta V by V is equal to how much? 3 times of delta L by L, right? Now multiply it with 100%. So delta v by v into 100%, this will be equal to how much? 3 times of delta L by L into 100%, right? Now what is this thing? What is this thing? See, this thing is the change in the that is change in volume over original volume into 100%, which is what? The percentage change, that is the percentage error, right? Percentage error in volume, right? So this will be equal to 3 times of percentage error in length, right? So that means percentage error, so my bad, this is volume, right? Percentage error in volume. So percentage error in volume would be how much? 3 times of what is the percentage error in length? Plus minus of 4%, right? So that means I can write from here plus minus of 4%, right? So that means percentage error in volume would be how much? This will be equal to plus minus of 12%, right? Now put this in this equation, so that means I can write that the percentage error in our density would be equal to plus minus 8% plus percentage error in volume is plus minus of how much? 12%. So that means the percentage error in density is how much? Is equal to plus minus of 20%, right? So it is option D. So I hope you got the question. So proceeding on to the next question, we have a truck which is moving at an initial speed of 20 meter per second. So u will be how much? Initial speed will be 20 meter per second, and it decelerates at 4 meter per second square, right? So acceleration is what? Negative of deceleration, right? Which is equal to 4 meter per second square. Now what is the distance traveled by the truck to stop? Okay, so that means when the truck will stop, its final velocity would be equal to 0, right? So now we know the formula that final velocity is equal to how much? Initial velocity plus acceleration into time, right? So that means, see, final velocity is 0. What is initial velocity? U, 20 meter per second, right? What is acceleration? Minus 4 meter per second square. So minus 4 times of t. So from here we find that t is equal to 5 seconds, right? So that means we found out that after 5 seconds, what will happen? After 5 seconds, the truck will stop. Now, what will be the distance traveled by the truck in 5 seconds, right? Well, u is equal to ut plus half ats square. S equal to, right? So what is s? Distance, right? So distance equal to u. What is u? 20. What is the time? 5, right? Plus half. What is acceleration given? Minus 4, right? And what is time squared? Time squared will be how much? 25, right? So that means from here s will be equal to 50 meter, right? So that means the truck will come to stop after 5 seconds and travel a distance of how much? 50 meters. So this will be your option. So in this question it states that the runner starts from rest. So that means the initial velocity of the runner would be equal to how much? 0, right? U would be equal to 0, and it accelerates at a constant rate, right? So the acceleration would be a constant. So acceleration is a constant quantity, okay? Now which of the graph shows the variation of speed v and the distance traveled by the runner? Okay, so we know that when acceleration is a constant quantity, we can write this relationship, right? Final velocity whole squared is equal to initial velocity whole squared plus 2 into a into s, right? And initial velocity is given to be 0. So that means I can write that final velocity whole squared would be equal to 2 into a into s, right? Now acceleration is a constant quantity, right? So 2a would be also a constant quantity, right? So over here, now what can I do is that, see, in all of the 4 graphs on the y-axis v is being plotted, right? So that means instead of v I just plot y. So y square equal to, now in all of the 4 graphs on the x-axis, displacement or distance is being plotted, right? Distance is being plotted. So in place of distance, that is s, I plot x. So that means 2a into x, right? So this will be the equation of the motion. So this will be the equation of the motion of the runner, okay? So that means y square equal to 2ax would be equal to a parabola, right? And we know that for a parabola there are 2 types of parabola. Y square is equal to 4ax, right? So this is a parabola. So this parabola goes like this, right? And there is another type of parabola which is x square equal to 4ay, right? So this parabola goes like this, so this equation matches to this parabola, right? So that means the option will be option number A. So I hope you got the question. So proceeding on to the next question, we have a projectile is fired at an angle to the horizontal, right? And the path of the projectile is shown, right? So that means on the y-axis, we have the vertical displacement of the projectile, and on the x-axis, we have the horizontal displacement of the projectile, right? So in the question, it states that which gives the magnitude of the horizontal component and the magnitude of the vertical component. So underline this, right? Magnitude of the horizontal component and the magnitude of the vertical component of the velocity of the projectile between the points O and P. So whatever we are talking in between these 2 points, right? Point O and point P, right? So that means, see, this type of question may look a difficult question, but it's actually on the easier side if you just think this question, right? So that means over here, see, between point O and point P, we have to consider the horizontal component and the vertical component of velocity, right? See, is the point O the maximum possible vertical displacement? Yes, because above point O, there is no vertical displacement, right? See, over here, suppose I have a projectile, right? Suppose I have a projectile that I have thrown, okay? What does the projectile do at the highest most point? Does it go up further? No. At the highest most point, so this, suppose this is the maximum height h of the projectile, right? At the highest most point, the velocity of the projectile vy along the y-axis is 0, right? Why is it 0? Because if it had been more than 0, it will further go up, right? But it's not going up anymore. This is the maximum height, right? So that means at the maximum height of the projectile, what happens? The vertical displacement, the vertical velocity becomes 0, right? See, over here point O is nothing but the maximum distance, vertical distance, right? So that means point O is corresponding to the maximum height of the projectile, right? So what happens after point 2? The projectile, so suppose this is our point 2, right, which is at the maximum height of a given projectile, right? So what happens after the projectile? So what happens after point 2? The projectile just falls, right? The projectile just falls in this path to the ground, right? So that means the end of the motion is predicated by point P, right? So this will be our point P, right? So I just draw an analogy between the graph and the normal projectile, right, that we throw. Okay, so now all the points that will be considered between this point O and this point P, right? Now the magnitude of the horizontal component of velocity, right? So the magnitude of the horizontal component of velocity, that is Vx, is obviously constant in a projectile motion. Why? Vx is constant because there is no acceleration along the x-axis, right? No wind is blowing up along the x-axis, right? So that means acceleration along x-axis is 0. That's why the velocity along x-axis is always 0, right? So that means which are the options where the horizontal component of velocity is constant? C and D, right? So that means automatically A and B are rejected, right? Now we have to choose the answer between C and D, right? So this will come from the vertical component of velocity, right? C, the vertical component of velocity. Okay, what did we discuss at this point right now? At the maximum height, what happens? The vertical component of velocity Vy is 0, right? After that, what happens? See, after that, what happens is that, see, in the y-axis, acceleration is what? Gravitational force is acting downward, right? So that means acceleration due to gravity is downward, right? So as it is downward, we take the downward at the negative axis, right? So that means Ay is equal to minus G, right? So that means what happens is that after some time the velocity along y-axis, so this will be equal to the initial velocity along y-axis, that is 0 plus acceleration into time, so that is minus g times of t, right? So that means the velocity of the along the y-axis is minus of gt, right? But what they are asking, see, it's very important, they are asking the magnitude of the vertical velocity. Okay, take the magnitude of the vertical velocity would be g times of t, right? As the time is increasing, right, as the time is increasing means as it's progressing further from the maximum height, okay, what is happening? Vy is increasing, right? So that means the vertical component of velocity would increase. So that means this option is correct. So option C is correct. Okay, it's a good question. The main thing is that whenever they are trying to give you something difficult, try to think how can you make it simple in terms of what you have learned. Okay, so in this question it is given that there is a mass m that is attached to a string of length r, right? So that means this string would be of length r. Okay, this string would be of length r and it moves in a vertical circle with a constant speed, right? So that means it's moving in this vertical circle. Okay, so it's traveling from the bottom of the circle to the top of the circle with a constant speed. So the tension in the spring at the top of the circle is T. Okay, so we have to find the kinetic energy at the top of the circle of the mass m. Okay, so if I just draw the free body diagram of m at the top of the circle, what will we get? So this will be our body, that will be our m, right? Now over here non-contact force will be mg, so that means mg force will be acting downwards, right? Again tension will act away from the body, right? So that means the tension T would be acting away from the body T, and the net acceleration would be towards the center, which will be equal to how much? V square by r, right? So from here I can write that summation of net force along the y-axis is equal to m times of acceleration along the y-axis. So net force along the y-axis is what? Mg plus T, right? So Mg plus T is equal to m times of what is the acceleration along y-axis? V square by r. So V square by r. So from here if I can find V square will be equal to r times of mg plus T divided by m, right? Now, so what we need kinetic energy, and we know that kinetic energy is what is equal to half mv square, right? So that means we found out v square to be this. So just substitute over here half m. So what is v square? R times of mg plus t divided by m, right? Divided by m. So let me just rub this, okay, over here. It's getting messy. So over here divided by m, so gets cut, so this will be r times of mg plus t divided by 2. So that means the option will be option number A. So proceeding on to the next question, it states that a compressed spring is used to launch an object in a horizontal frictionless plane. So there is no friction. When the spring is compressed through a distance x and release, the object moves with a speed v. Okay, so that means over here, so suppose this is the natural state of the spring, right, and it's being compressed to distance x. So that means the compression of the spring would be how much? Delta x would be equal to x, right? Now this compression creates an energy in the spring, right, and which on release the spring transfers the energy to the body, right? So that means I can write that the spring energy is actually being converted into the kinetic energy of the block, right? So that means the spring energy will be how much? Half k into compression is how much? X, so x square. So this is being converted into the kinetic energy of the body, which is half mv square. So from here I can found that the velocity of the body is under root of k by m into x. Now proceeding on to the question, what is the distance through which the spring must be compressed for the object to leave the spring at v by 2, right? So that means, suppose I have this spring. Now suppose I compress the spring y. Okay, so I'm compressing the spring y such that when I just leave the spring, what happens? The spring goes to its original position and the block moves forward with a speed of how much? V by 2, right? So that means over here also what happens is that kinetic energy, okay, the spring energy is being converted into kinetic energy. So half k into delta x whole square. So over here delta x would be y, because it is compressed y from its initial state. So half k delta x square would be the spring energy, which will be equal to half k into y squared, right? Now this half k into y squared, which is the spring energy, it is being converted into what? It's being converted into the kinetic energy of the body, right? So that means I can write that this is equal to half m. Now what is the velocity? V by 2, right? So v by 2 whole squared. So now if I just solve from here, what will I get? So I want y. What distance must be compressed so that it moves with the speed of v by 2, right? So that means over here half k y square would be equal to how much? Half m into v square by 4, right? Now over here, from here, y would be equal to how much? Y would be equal to your this will be equal to your m by k under root, okay, v by 2. Okay, just basic calculation, you can do it. Okay, now what is v by 2? We calculate v to be this. So v by 2 would be equal to how much? So this will be under root of m by k. V by 2 would be equal to 1 by 2 root over of k by m into x, right? Root over of k by m into x. Okay, so cut this and this. So that means this will be equal to your x by 2. So that means the spring must be compressed by x by 2 such that the spring leaves at a speed of v by 2. I hope you. Proceeding on to the next question, three forces act on a point. Okay, so in which of the diagram this point is in equilibrium, right? So we know that, okay, so we have taught this in the chapter of vectors that for three forces to be in equilibrium, what should happen? So this is the normal case that we teach. Okay, so that means for three forces to be in equilibrium, what should happen is that the magnitude of the three forces should be equal, right? So that means I can tell you that this vector, okay, this vector should have a magnitude f, this vector should have a magnitude f, and this vector should have a magnitude f, and they should be symmetric, right? See that this vector and this vector is symmetric, and the angle between these three vectors individual should be 120 degree. So see, either of these three angle is 120 degree, right? So can I say right up front is the option C is the correct answer? Can I say that? No, I can't say. Why I can't say? Because see, in option C, the length of these two vectors are equal, but it's not equal to our F3 vector. Okay, so that means option C is our incorrect answer. Okay, so now comes option number D, right? Option number D. No, so as we know that equilibrium, for equilibrium what should happen, summation of net force along y-axis should also be equal to 0, right? So what is the component of F2 vector along y-axis? Okay, so just let me just draw the component of F2 vector along y-axis. So this will be the component of F2 vector along y-axis, and this will be the component of F1 vector along y-axis, right? So this is the component of F2 vector along y-axis, and this is the component of F1 vector along y-axis, right? See, which vector is greater? This vector is greater, so the net, so they will get a net upward vector, right, on adding these two up. So the summation of net force along the y-axis for this case is not equal to 0, right? So that means option D is also our incorrect answer. So proceeding on to option number A. Okay, so see that in option number A what is happening is that, see, again just taking the component of vectors in the y direction. What is the component of F2 vector along y direction? This is the component, right? And what is the component of F1 vector along y direction? This is the component, far much greater than F2 component, right? So that means we have a net downward component. Okay, downward component, right? So that means in this case also the summation of net force along y-axis is not equal to 0. So for this also this is an incorrect option. So the only option is viable, which is option number B. See, in option number B what is happening? See, option number B, what is happening is that in the y-axis what is happening, see, they are of equal magnitude, right? These two vectors are of equal magnitude, so this is equal to this. So the summation of net force along y-axis is equal to summation of net force along y-axis is equal to your 0, right? Is equal to your 0. So that means option number B is your correct answer. Okay, so so I did this question by elimination. It's definitely on the slight tougher side. Okay, so for the tougher questions you can opt for the option of elimination. Okay, so proceeding on to the next question, it is stating that a solid substance has just reached its melting point, right? So suppose this is the solid substance, right, such that it has just reached its melting point, right? So now thermal energy is being supplied to the substance at a constant rate. What graph shows the variation of temperature with the energy supplied, right? So see, first of all, it has just reached its melting point, right? So that means energy supplied. Now as we supply in energy to this matter, what will happen? The energy will be used to change its state, right? So this energy will be used to change its state from solid to liquid, right? So that means the energy will be used to change its state from solid to liquid while maintaining constant temperature. So in the process what will happen? There will be constant temperature, right? There will be constant temperature, right? Now after the state of the liquid, after the state of the solid has been changed to liquid, what will happen? Any more further addition of energy, what will happen? The temperature will then start to rise. What will happen? Any more further addition of thermal energy will cause its temperature to rise, right? So that means what is happening? See, first of all, it went from melting point to the liquid, right? Because at this point in time this was solid, all the energy was used to convert it into liquid, right, while maintaining a constant temperature. After that what happened? After that, as we supplied energy, its temperature increased, right? That means the water is getting heated, Okay, so that means the correct answer will be option number C. See the option number C, first of all the temperature is constant, then the temperature is increasing on addition of excess thermal energy, right? So this will be the answer to question number 8. So proceeding on to the next question, we have a container is filled with a mixture of helium gas and oxygen gas at the same temperature, right? So that means this is the container in which we have helium gas and we have oxygen gas that are put together at the same temperature T. So helium gas is also put in the container at the T temperature, and oxygen gas is also put at the container at T temperature, right? So the molar mass of helium, so the molar mass of helium is given to be how much? Is given to be 4 gram per mole, right? 4 gram per mole. And the oxygen is given to be, so the molar mass of oxygen, okay, it's given to be how much? 32 gram per mole, right? So now we have to find the ratio of the average speed, right? So we know that average speed of the gas molecule is nothing but the RMS speed, right? So this is Vrms. So what is Vrms? Vrms is calculated by root over of 3 RT by M, right? Where T is temperature, M is molar mass, right? So over here, see, so the RMS speed, that is the average speed of helium molecule, would be equal to how much? Root over of 3 R T of helium, right, divided by the molar mass of helium, right? Again, the RMS speed of oxygen would be given as under root of 3R temperature of the oxygen, right, divided by molar mass of oxygen, right? Molar mass of oxygen. Now divide these two equations, right? So that means Vrms of helium, I'm not writing RMS, it will become messy, divided by Vrms of oxygen. So this will be equal to, so this will give our, okay, this will give under root of, if you just divide it will get, okay, so this will give the under root of molar mass of oxygen divided by the molar mass of helium, right? Just dividing these two equations you can do it, okay? So over here what we'll have, so the RMS speed or the average speed of the helium molecule divided by average speed of oxygen molecule, so this will be equal to, now what is the mass of the oxygen molecule? It's given to be how much? 32 gram per mole, right? So this will be equal to under root 32 divided by, okay, just a second, over here helium temperature and oxygen temperature is same, so I have just cut out, okay, that, because temperature of helium is equal to the temperature of oxygen, right? Because they are put at the same temperature, right? They are put at the same temperature. So over here what will be the molar mass of helium? Coming to the question, molar mass of helium is given to be how much? 4. So this will be equal to your root 8, right? So that means the answer would be root 8, which is option C. So proceeding on to the next question, we have a container X contains 1 mole of ideal gas, right? So suppose this is our container X, okay? So this is our container X. So it contains how much? 1 mole of ideal gas, right? So I'm writing 1 mole. And there is our container Y, right? So there is our container Y. So this is our container Y. Now our container Y, so this is our container Y, right? And our container Y contains 2 mole of ideal gas, right, given in the question. Y has 4 more times the volume of X, right? So that means if this volume is V1, so this volume will be how much? 4 times of the volume of X, that is 4 times of V1, right? Pressure in X is twice in that of Y, right? So that means over here is, if pressure is P1, over here the pressure will be twice of P1. Why? Because the pressure is twice in X than in Y, right? Now what is temperature in gas X divided by temperature of gas in Y? So now applying the equation PV equal to nRT for the first container, that is container X, right? So what is pressure? The pressure in the first container is twice of P1. What is the volume of the first container? V1, which is equal to N. What is the number of moles of the gases in the first container, which is equal to 1 mole given in the question. R is the universal constant, and T, suppose the temperature of the first container be T1, okay? Now over again applying PV equal to nRT. For the second container, we get what is the pressure in the second container, P1, right? What is the volume of the second container, 4 times of V1, right? So this is equal to what is the number of moles of gases in the second container, 2 moles of gases. What is the R is the universal gas constant. And what is the temperature of the second container? Second container temperature is suppose T2, right? So this is our equation number 1, this is our equation number 2. Now divide equation 1 by equation 2. So I can write that twice of P1 V1 divided by P1 into 4 V1. This can be written as equal to T1 into R divided by twice into R into T2. Right, now cut everything. So R is cut by R, P1 is cut by P1, V1 is cut by V1, right? So from here we get that, 1 by 2. So this is equal to how much? T1 by twice of T2, right? So from here we get that T1 is equal to T2, right? So that means the temperature of the gas X is equal to the temperature of the gas Y. So that means the ratio would be option C, 1. So this is the answer to the question number 10. So proceeding on to the next question, we have a particle moving in a circle completes 5 revolutions in 3 seconds, right? So that means 5 revolutions it completes in 3 seconds, right? So what is 1 revolution, right? So 1 revolution is nothing but 2 pi radians, right? So that means 1 revolution means are 2 pi radians, right? So that means 5 revolution would mean how much? 10 pi radians, right? Simple multiplication, 10 pi radians, right? So that means the particle completes 10 pi radians in 3 seconds. 3 seconds, right? Now what is 10 pi radians? That is the angle rotated by the particle, right? So that means this is theta. And what is 3 seconds? 3 seconds is nothing but time in which it rotated 10 pi radians. So that means our omega, which is equal to theta divided by time. So this will be equal to how much? So this will be equal to 10 pi by 3, right? Now what is the frequency, right? So now we need to calculate the frequency, right? So we know that omega is equal to 2 pi into frequency, right? So that means what is omega? Omega is 10 pi by 3, right? So this will be equal to 2 pi into frequency, right? So this will be the frequency f. So f will be equal to 5 by 3, right? So f will be equal to 5 by 3, unit of f will be equal to hertz. So that means option B would be the correct option. So proceeding on to the next question, we have a longitudinal wave moves through a medium. The relative to the direction of the energy transfer through the medium, what are the displacement of the medium? Displacement of the medium and the direction of the propagation of the wave, right? So these two will it be parallel or will it be perpendicular, right? So we know that suppose this is the longitudinal wave, right? So suppose this is the longitudinal wave, the direction of the propagation of the wave, suppose this be the direction of the propagation of the wave. So we know that from the theory of longitudinal waves that the energy propagation is parallel to the wave propagation, right? Energy propagation is parallel to the wave propagation. So that means if the wave be traveling in this direction, right, the energy propagation would be parallel, right? So the energy will be in this direction only. Okay, so proceeding on to the next point, we also know that the displacement of the medium is also parallel to the wave propagation, right? So that means suppose the wave propagation is happening in this manner for this wave, right? The displacement of the medium will also happen parallel to the direction of the wave propagation, right? Which is in fact parallel to the energy propagation, right? So that means the displacement of the medium will be parallel to the energy propagation, So that means both of them would be parallel to the energy propagation, and that is option number B. So proceeding on to the next question, we have L is the point source of light, right? So that means suppose this be L. So what do you mean by point source of light? It emits light. That means it is emitting light in all the possible directions, right? So that means it's emitting light in all the possible directions, right? So in the question it is stated that the intensity of the light at a distance 2x is I, right? So suppose this is the point 1. Okay, so this is the point 1. So point 1 is located at a distance 2x, right? And its intensity of this point is I, right? So that means the distance of point 1, which is equal to r1 from the light source, is what? 2x, right? And its intensity, suppose its intensity I1 is equal to how much? Its intensity I1 will be equal to I, that is given in the question, right? Now in the question it is stated that what is the intensity at the distance 3x from L, right? So suppose this is the same light source, right? And we need to go a distance of 3x and we need to find the intensity, right? So suppose at a point distance 2x we considered the point 2, right? So that means what is the distance of the point 2 from the light source? R2 will be equal to 3x, right? And what is the intensity of the light at point 2? So we converted the question from the descriptive point of view to a pictorial form, right? So now from here it gets easy, okay? So we know the formula that I2 divided by I1, that is intensity at a point 2 divided by the intensity at a point 1, is equal to R1 by R2 whole square, right? What is R1? Distance of the point 1, and R2 is distance of the point 2, right? So what is I2? I2 is K, we need to find out, right? So what is I1? I1 is given to be in the question as I, right? So this is equal to, so what is R1 by R2? See, R1 by R2 will be 2x by 3x, right? So this will be equal to whole square, right? So from here we find that, so from here K comes out to be 4 by 9 times of I, right? 2 square divided by 3 square, right? 4 by 9. So that means for question number 13, option A is the correct answer. So proceeding on to the next question, we have x and y are two coherent sources of waves, right? So x and y are two coherent sources of waves, right? The phase difference between x and y is 0, right? So that means the phase difference, that is phi, between x and y, so this is given in the question as 0, right? The intensity at point P due to x is I, so x alone is giving an intensity I on point P, and y alone will be giving an intensity I on point P, and we have to find the resultant intensity at point P, right? So we know that the resultant intensity at point P, right, so this will be equal to what? Resultant intensity at point P due to x, which is equal to I, right, plus resultant intensity at point P due to y, which is equal to I, right, plus 2 root resulting intensity due to at point P due to x is I, multiplied by again the resultant intensity at point P due to y, into cos phi. What is cos phi? Phi is what? 0 into cos 0, right? Just applying the equation, the relation to solve the problem, right? So that means the resulting intensity at point P would be equal to your 4i. Solve from here, this will be equal to 4i, and the option will be option number D. So proceeding on to the next question, we have light is incident at a boundary between air and diamond, right? The speed of the light in diamond is less than the speed of the light in air, right? So what they are saying, that the speed of the light in air is greater than the speed of the light in diamond, right? Okay, so we also know that the velocity is inversely proportional to the refractive index, right? So that means I can write that the refractive index of air is actually less than the refractive index of diamond, right? So that means the diamond has a greater refractive index. More the refractive index, more is the denser the medium, right? So that means the diamond over here, diamond will be our denser medium, so diamond will be our denser medium, okay, and air will be our rarer medium, right? Air will be our rarer medium, okay. Now we know that when light travels from a denser medium to a rarer medium, okay, with an angle greater than the critical angle, what happens? Yeah, you know this phenomena is called the total internal reflection, that is TIR. In total internal reflection, what happens is that every possible bit of the light that is incident is being reflected back. None of it is refracted, right? So that means what happens is that the total light will be reflected, right, when the light is traveling from diamond, that is the denser medium, to air, that is the rarer medium. Okay, so which options match? The light must travel from diamond to air, right? So either option A or option B. But and the second condition is all of the ray must be reflected back, right? Because the angle is greater than the critical angle. So the correct answer will be option number A, because in option number A all of the light is reflected back. So this is the answer to the question number 15. So proceeding on to the next question, a wire of length L, right? So suppose there is a wire of length L, okay, it's used in an electric heater. So when the potential difference applied across the wire is 200 volt, right? So suppose this is the tip of the wire A and this is the end of the wire B. So it's given that the potential difference VAB that is applied in the wire is how much? VAB applied in the wire is 200 volt. Okay, and the power that is generated in the wire is how much? Power generated in the wire AB is how much? Is actually equal to your 1000 watt, right? So we can use the formula, power is equal to your V square by R, right? So what is the power in the wire AB? Power in the wire AB is 1000 is equal to what is V? Okay, what is V? V is given to be 200, right? So 200 square divided by R. So from here we get that the resistance of the wire is how much? Is equal to 40 ohms. Okay, now proceeding on to the question. The same potential difference is applied across a similar wire of length 2L. So I have a similar wire, right? So suppose this is the tip of the wire, this is the end of the wire, and the wire is having a length of 2L, right? So over here I can write that, what can I write? Power, again power produced in the wire AB. Okay, so just let me specify. Power produced in the wire AB, this will be equal to potential difference applied in the wire AB whole square divided by resistance of the wire, right? So let the resistance of this wire be R1. Okay, so over here I can tell that, okay, what is PAB we need to find out. So we need to find out PAB, but it's given that the same potential difference is being applied. So VAB is how much? 200 volt. So this will be equal to your 200 whole square divided by the resistance R1. Now we need to find the resistance R1. Okay, so will the resistance change? Yeah, the resistance will change, see, because the length is increased from L to 2L, right? But it's being stated that it's a similar wire. That means its cross sectional area and this wire's cross sectional area will be the same, right? So this is the meaning of this similar wire, right? So that means I can write that R1 will be equal to rho into what is the length of the this wire. This wire is length is 2L by A, and we can add also that R2, okay, not R2, the resistance of the original wire, that is R. What was the resistance? Rho into what is the length of the wire? L by A. Now the cross sectional area of the two wires will be similar. Why? Because they are the same wire, okay, similar wire. Okay, so over here I can write that R1 is equal to twice of R2. Okay, why can I write that? Just divide these two equations, you will get it. Okay, so from here I can write that R1 will be equal to how much? Twice of R2 will be equal to your 80 volts. Okay, 80 ohms, my bad. Okay, so that means the power that is generated in the wire AB, so this will be equal to your 200 square divided by your 80. So this will be equal to your 500 watt. So I hope you got the question. The answer will be option B, 500 watt. So proceeding on to the next question, we have circuit. Okay, in the circuit there are 4 resistance, each of individual resistance R. So this has resistance R, this has resistance R, this is also R, this is also R. So what is the current in the resistor X? Okay, so first of all we need to find out the equivalent circuit, right? See over here, this resistor and this resistor are in series, right? So that means I can just combine this. So this resistor is of resistance R and this is also of resistance R, right? So that means the circuit will be, so this will be our EMF to the circuit, that is E, right? Okay, now over here, so these two are in series, right? So this will be equivalent R plus R, that means 2R, right? So this will be 2R. Over here was our R, right? So over here was our R, and over here was a resistor X of resistance R, right? Now what is happening, see, 2R and R now are also in parallel. Why? Because they have the same endings, right? So that means they have the same potential difference, right? So that means current is being divided, right? So that means they are in parallel. Okay, so over here if 2 and if that means 2R and R are in parallel, right? So what will be the equivalent of 2R and R? So R equivalent for two resistances in parallel is what? 2R into R divided by 2R plus R. So that means this will be equal to your 2R square. So this will be equal to your 2R square divided by 3R. So this will be equal to, the equivalent resistance will be equal to 2R by 3, right? So that means this circuit can be again replaced as in something like this, right? So that means this is our EMF E. So over here this will be the equivalent. So what is the equivalent? 2R by 3, right, formed by the 2R and R, right? And over here this was our resistor R, right? Okay, so again see that this resistor R and 2R by 3 are in series, right? So over here the equivalent circuit becomes, see, so this will be our EMF E, and this is our what? This is our, so what is the equivalent of 2R by 3 and R? They are in series, right? So that means I can write 2R by 3 plus R, so they will come out to be equal to 5R by 3. So that means over here the equivalent resistance is 5R by 3, right? So that means what is the current in the circuit? I. So I would be equal to E by equivalent resistance, that is 5R by 3. So I'm putting 3 to the above side. So that means I got the current I in the circuit to be 3E by 5R. So what is the current I? So current I in this circuit is this, but in the original circuit current I is actually this. Okay, is actually this is the current I, which is the 3E by 5R. See, current I is actually this, right? In this branch it will flow in this branch. So that means in the original circuit also this will flow in this branch, right? So this is our current I. Now we need to find out the current in this branch, right? In this branch. Okay, so this is our resistor R, right? And this is our resistor 2R, which are in parallel, right? So this is 2R, this is R, right? And in this manner I is coming out, I is coming, right? In this manner I is coming. So we have to find the current, that is I2, in the circuit R. Okay, so I would be divided into I2 and I1, right? So what will happen is that this current I would be divided into two currents, right? So over here it will be divided into current I1 and this will be divided into the current I2. Why it's getting divided? Because it's parallel connection. In parallel connection what happens? The net currents get divided into sub currents. Okay, so we need to find the current I1, right? So this will be, so this is the current I1, right? So how will you find the current I1? Okay, there is a very easy formula for this. Okay, so I1 would be equal to, first of all write the opposite resistance. What is the opposite resistance? 2R, right? So this will be equal to 2R divided by, okay, so now we need to sum up the resistances, that is R and 2R. So this will be equal to 2R plus R. Now this will be equal to, multiply it with the original current that is flowing in the circuit. So this is I. So that means I1 would be equal to your 2 by 3 times of I. Similarly for I2, how can you find I2? I2 can be found out by, okay, I2 can be found out by, see, this is I2. What is the opposite resistance to I2? R. So this is R, right? Divided by the two resistances, that is R plus 2R. So that means divided by to R plus 2R of the original current. What is the original current? I. So that means I2 would be equal to your 1 by 3 times of I. Okay, so but what do we want? We want I1, right? That is the current flowing through the resistor R, right? So this current would be equal to, I1 would be equal to 2 by 3 times of I. So what is I? We found out I is 3e by 5r, right? So multiply it by 3e by 5r, right? So from here we get that the net current, that is I1, that is flowing through the resistor X, is nothing but 2e by 5r. So over here we get that. So this will be equal to 2e by 5r, and this is option number C. For 17 question, the answer is option number C. So proceeding on to the next question, we have the two parallel wires P and Q, which are perpendicular to the page, okay, and they current and they carry equal currents, okay. Point S is the same distance from both the wires, right? So that means I can write that this is at the same distance S, it is also at the same distance S, right? So the arrow shows the magnetic field at S due to P and Q, right? We have to find the directions of currents in P and Q for that to be possible, okay. So if the direction of current in P is inward, what will happen? Put your thumb in the inward direction of the paper, okay, and rotate the other four fingers, okay. What will you get? Get the net magnetic field in S in this direction, right? And suppose you take the current direction in Q to be outward, okay. So that means I'm taking the current direction in Q to be outward. Now put your thumb in the outward direction of the paper, okay, and rotate the other four fingers, okay. Rotate the other four fingers. Then in which direction you'll get the magnetic field at S? See, in this direction you will get the magnetic field at S, right? So that means just try this at your home, okay, you will get this, okay. So that means, see, when I'll add these two up, right, we'll get this vector, that is the form due to addition of two vectors. We learned in the chapter of vectors, right? So that means over here the current P, the current in the wire P should be into the page, right? Should be into the page, and the current in the wire Q should be out of the page, right? So that means this will be option number A. So proceeding on to the next question, it is given that a particle of mass m and charge q, right? So the particle is having a mass m and the charge of the particle is q, right? Enters into a region of uniform magnetic field that is directed into the page, right? So we have to find the speed and the charge of the particle. For which it follows this trajectory, right? For which it follows this trajectory of a circle of radius r, right? Now we have discussed this in our videos, okay. See, what happens is that since the radius of the this is the radius, right, and this is the center, right? So along the center, so this is the radius, right? So what will happen? Along the center there will be the net force, right? Along the center there will be the net force that is exerted on the particle, right? So that means the net force exerted on the particle will be along the center, right? It will be along the center, okay. And what is the net force? The net force is BQV, right? BQV, right? We have taught this in our videos, right? Now what will be the acceleration along the center? So we know that the acceleration along the center will be directed towards the center, right? And the acceleration would be v square by r, right? Centripetal acceleration. So over here what can I write? The summation of force along the center O is equal to, so this will be along the center, okay, O. So this will be equal to mass into the acceleration along the center O, that is the centripetal acceleration. So BQV will be equal to your mv square by r, right? Mv square by r, calling this the radius be r, right? So that means from here we get that r will be equal to your no, we need the speed of the particle, right? So that means from here if you just calculate, the speed of the particle will come to be bqr by m. So it can be written as qbr, right? Qbr by m. Okay, so which of the following options match? Either this or this, right? Eliminating options, right? Always try to eliminate options. Solve one part, eliminate options, right? It becomes easier, it gives you confidence more. Okay, so proceeding on to the second part, we need to find the charge of the particle, right? Now what will be the charge of the particle? See, first of all, put your hands, okay, put your thumb in the direction of the velocity, okay. So put your thumb in this direction, okay. Everyone do that watching this video. Put your thumb in this direction, right? and put the rest of the four fingers, okay, into the paper, right? So that means down from here, right? So that means down from here into the paper. Okay, so where will you get the direction of the force? You'll get the direction of the force in this direction, right? If you do this, you'll get the direction of the force BQV in this direction, right? But we want the force direction to be where? In this direction, right? So this was for our positive particle. Okay, the method that we followed was for positive particles, but for negative particles what happens? The direction just reverses, right? So that means the particle charge must be negative and the velocity must be qbr by m. So this is our correct option, and the option number is option number B. So proceeding on to question number 20. So it says that in Rutherford Geiger Marsden scattering experiment, it was observed that a small percentage of alpha particles are deflected through large angles, right? And the three features of atoms are, and they have given three features of atom. Nucleus is positively charged, nucleus contains neutrons, nucleus is much smaller than the atom, right? So first of all, you have to focus on this statement that a small percentage of alpha particles are deflected. Why is that deflected? See, when alpha particles are being projected, okay, the nucleus is very small compared to the rest of the atom, right? So suppose this is the rest of the atom and this is the nucleus, right? So the nucleus is very small, so a very small number of alpha particles will collide with the nucleus and get deflected through large angles, right? So that means what is happening is that the nucleus, as it is very small, okay, that's why very small number of alpha particles are being deflected, which in turn states the small percentage of alpha particles are deflected, right? So that means the nucleus is very small, okay, I can say from there, right? Now, as why are the alpha particles being deflected, right? Alpha particles are positively charged, right? Had been the nucleus been negatively charged, it would not be deflected, right? Nucleus would attract the alpha particles, but since they are deflected through large angles, we can conclude that the nucleus must be positive in charge, right? Because positive and positive repel each other, so when they'll try to collide, they will get deflected through large angles, right? So that means option A can be also inferred from this statement. So that means nucleus is positively charged. So option 1 and option 3 only. So that means this is option B is the correct answer to question number 20.